All right.
Okay, thanks, Claudio. Good morning. My name is Kenji Rikitake. I'm very glad to come back here again, and this is my 8th presentation at the San Francisco Erlang and Elixir factory since 2010. Okay, in this talk, I'm going to talk about what to do if you want to commit your code to Erlang OTP itself. And I will be talking about my own experience. So what I did for OTP, I've written 6 implementations of random number code for Erlang since July 2010. They are all on GitHub, so feel free to look them up. And I've tested and published the results at many places, including past years of this conference, namely 2011 and 2015. And at HEML workshops, I submitted and got the papers accepted 2 times in 2011 and 2012. And after doing this random number stuff for nearly 5 years, now the code is a part of OTP since OTP 18. And you'll be getting a major revision at OTP 20. It's already available on the master branch, but the official release will be on July 2017. You'll be getting the details on tomorrow's presentation by Lucas Ralston about the OTP status or OTP State of the Union. Okay, this talk is not about technical talk. I've already given multiple talks at Erlang Factory on the details of pseudo-number random generators and their algorithms and the implementation details. And for all of those stuff, I don't want to make a duplicate on this presentation. And if you have any interest on all of the technical details, you can see the video archive, the YouTube of the Erlang Factory. Of course, I'll be glad to answer those questions during the conference. I'll take them. Just feel free feel free to ask me for that. But I will not go into the details in this presentation. On the other hand, in this talk, what this talk is about, I will explain what I've learned from writing an OTP Erlang module for the OTP itself. And I will include the 3 major topics: developing software for OTP, working with the OTP team, and how to gain the community support of your code. Okay, let's get to the first topic. I'd like to talk about software development for Erlang OTP. Yeah, why new code? There are many reasons for writing a new piece of code. The most critical one is for fixing a bug and closing the security holes. And there will be a need for support for new devices. I think that's one of the most important things to do on writing new code. And of course, people want new features or even some cool stuff. And some people may say they want to change or fix what they don't like, although I don't recommend it because it turns out to be an argument, and which is not a creative argument. So I don't recommend to do so. The bottom line is that if you want to commit the code, do it for everybody. Do it for everybody, please. Okay. Before trying to commit your code to OTP, you need to think carefully before making a change to the OTP. OTP is for all Erlang users. All Erlang users no longer means just Erlang users. All Elixir users are affected by this, and all LFE users are affected by this. And I have to say that all OpenStack users are affected by this because RabbitMQ, a very long time Erlang product, has already become a part of the OpenStack. So when you're going to make a change, you have to be very careful, seriously speaking. And You also need to think about who needs the code. Is it for some specific implementation or some specific use? Or is it for a general change, like finding a, like a very critical bug? Like, yeah, there was an Elixir bug recently. Like, what should I say? There's a module in Elixir called plug, and it deals with the file paths, and that kind. And Joseph Alim immediately released the bug fix to the Elixir community, and that kind of thing must be done in a very fast manner and very widely, or otherwise there may be a real damage. But on the other hand, if you're going to put some new features, you have to discuss that a lot with other people or OTP people. Otherwise, you may prematurely put into the code and break something else, which is you want the least. So, talking about new feature, you got to be very conservative. And you also need to remember, once a piece of code is committed, removing it is a very difficult task. For example, random module, which will be deprecated, removed from OTP 20, and now is deprecated since OTP 19, has been there since 1998. If you track the whole logs of Erlang source code, which is huge, from Erlang version 8, not 18, 8, which is released in 1999, you still find the same code there as you find there in recent Erlang source code. So removing the old source code is very, very hard once it is being used by many people. So if you try to commit something, you have to think about that removal is very hard. Okay, so let me explain about the rationale for random module. The rationale for including random module was mainly to fix the security issues of random module. To make it short, the random module is exploitable by anyone who has Mac Mini or PC or laptop PC within less than 10 hours by C code. It only has 2 to the power of 43 sequences only. Think only, please. Then it's a big number, but it's just a short time for computer. So I propose some of the alternative algorithm, which has a 2 to the 64 period, or 2 to the 116 period, or even longer, 2 to the 1024 period. And these longer periods may satisfy the need of lesser possibility of being exploited. And there's another need. The second one is a better API, because the random module, the random function, the seeding function of random module, random column seed /0 or /1, it has a serious deficiency that when you use the random seed, or when you use a random uniform, or better say a random function itself without any initialization, you will almost always get the same result. So it's not random at all. If you just call the random uniform at the different processes, you will get the same result. If you fail to initialize with something with external randomness, such as time or process number or that kind of factors. So on random module, everything is automatized instead. Once you call rand :uniform, you will get totally, not really totally, but trying hard to be totally different initialized parameter. So you don't have to worry about the randomness of the seeding itself. Okay, and the next thing is about multiple algorithms. I mentioned 3 algorithms, and those are already built into the RAND module, but the RAND module itself has a extendable architecture, so you can add more algorithm later, if you, at least if you know how. And there are many, there are other features that it provides, not only the uniform distribution, but a normal distribution. Normal distribution is what is used in the statistics, and it's also called Gaussian distribution. It represents the natural behaviors, natural behaviors, and it's also called a bell curve. And the other stuff. Okay, I have put another stuff in for the OTP 20. It is called the jump function, and the jump function is providing the result of the same result of equivalent result of the calculating a very huge number of sequential iteration, which is 2 to the power of 56 or 2 to the power of 64 or 512, so that by doing a jump once before initializing the random number, you can guarantee that the result of the different processes will not overlap practically. So these important, so that these new stuff are already into RAND modules. And one good thing is that the default algorithm of RAND module is still as fast as random module, even with the higher precision on the 64-bit computers. So it's not only my work, it's also there's a huge amount of work poured in by Dan Gudmundsen, OTP team maintainer, on this, so how to make the RAM module a better thing so that everyone will satisfy. So let me tell you about the bottom line. The important point is that you need to have a rationale that convinces all users of Erlang, not just Erlang, Elixir, LFE, or all community. Okay, let me talk about the prototyping. And when you decide to write your own Erlang module, the first thing you need to do is to make an independent repository. Independent means that you can isolate the code under development from the existing system, and this will make the testing much easier. And you also need to learn Common Test. Common Test is a testing framework which provides a unit test and some good features like concurrent test or being able to specify test sequence. Many OTP, many Erlang modules are provided on the eUnit. eUnit is good, but rewriting eUnit to Common Test is not that hard once you get learned to it. So if you want to put make your code compatible with OTP, you please use Common Test. And you need to learn Dialyzer. Dialyzer is a framework, not framework, it's a tool of providing static analysis of all code by the given type and data specifications. Providing formal type and data specification is very, very important on OTP because all OTP functions are with it. Without the type specification, your code will be 100% rejected. And the third one here, you also need to be fluent in Erlang DocGen. Erlang DocGen is XML-based documentation system, which I'm going to explain later. So this is a test case, a part of the test case I picked up from the run modules test case. First of all, in common test, you almost always put the keyword suite. And when you find the source code with that file name, it's a common test. It's a common test suite. So you can find many of these in the part of our source code. And in common test, you can define the sequences of the test in O/0 function. It's over here. And you literally list all the test case functions. In this case, begins with seed, interval, int, and it's going to interval float and all those stuff. And it ends with a group. Group is described by a tuple with the first element group and the group name over here. And what does group do? Group is the set of the test which has a common characteristics. When you specify the option of parallel into a group, which is listed under the function groups, all groups must be listed in the function of the groups. For example, on a group called basic stats, it's right here. There are three functions called basic stats uniform 1, uniform 2, and normal. And those tests are running concurrently or parallelly so that the execution time will be reduced in case of multi-core. And you can, in this case, you also have a reference jump, and there's a reference jump state and reference jump predict. And these two tests will run concurrently. So by using these kind of options wisely, you can shorten the time of testing without changing the sequence or other testing restrictions. So this is just an example of the common test feature. There are lots of features in common test. So, and I suggest you to run common test if you want to make a big system on Erlang, not only on OTP, but for all the other applications. Okay, and next, about Dialyzer. Dialyzer is very simple. All you've got to do is to make a file called PLT, which is templates before running a Dialyzer. And I will not talk about that. It's in the Dialyzer's manual. You can find it in the Dialyzer's manual. And it's built into Erlang.mk or Rebar 3 or other popular building tools. But on land module, there is one very interesting property that it uses an improper list right here. Improper means that the very end, very tail of the list element is not null. On Erlang, the tail element is supposed to be null to be proper. And why it should be, why it has to be that is that many of the lists module library assume that. Okay? But so, and also the Dialyzer assumes that all lists are proper lists. But sometimes in this rare case, actually Dan Gudmundsson, he used this very packed structure as an optimization for speed and memory. You have to disable the Dialyzer's function of detecting improper lists and give you the warning. So here's the directive I'm sorry, it's not the directive in Erlang, it says attribute. The dialyzer attribute with the function here, right here described, and with no improper list, don't check it. This is a flag. And in Rand module, we specify this this attribute for 4 of the functions. Okay, so the bottom line of here is that when you use Dialyzer, you have to use it wisely. Don't let the Dialyzer generate spurious warning messages. That will hide a much important one. Okay. All right. The next one, actually the last one for the prototyping is about the Erlang docgen. This is kind of hard to read XML document. This is the strict XML document, which is a part of the Rand module. And it's about the function explanation because it begins with func. And these tags are defined in Erlang docgen manual. So if you are interested in what these tags are doing, please refer to the Erlang docgen manual. And one thing you have to remember is that it's neither a markdown or restructured text or nor an HTML. It's not a simple HTML because you have to generate the HTML and PDF from the same file altogether with, during the build process. So it's an XML with specific tags. If you have to write a manual, you need to get accustomed to these tags for writing OTP manual. One good thing is that if you are familiar with the edoc format can be converted into this Erlang docgen format pretty easily. Okay, and here's the converted result with the dotted box. I only show the source code of here, right here. And this is a converted result during the prototyping phase of the documentation. So, if you want to work with Erlang OTP, you have to know 3 things: common test, Dialyzer, and Erlang docgen. Okay. Okay. Now, I'm going to talk about how to work with OTP team. I'm going to show you first a couple of tweets from Roy Kogan, the author of Cowboy, telling tips on getting your patches of pull requests merged, which is part of from tweet timeline on February 2017. Okay, I'm going to read this aloud first. How not to get changes merged. Send big patch without previous discussion. Get patch rejected with request for changes and not doing those changes requested. So, to summarize this, this tweet tells that sending a huge patch, or maybe of 100 lines or 1,000 lines or whatever, or entire file, abruptly, without a thorough discussion beforehand with someone else, will always be rejected because it's hard to deal, hard to verify, hard to analyze, and hard to test. So unless you're really sure with what you're doing, don't do this. Okay, and here comes the second consecutive tweet. I'm going to read it out too. How to get changes merged. Discuss big picture with maintainer. Write the changes one small step at a time. This doesn't necessarily mean one line for each, but one small chunk, maybe 5, one function or one data type per each. And submit them in small chunks. And this tweet tells that having a discussion on the broader goals with the maintainer beforehand about what you're doing and sending patches in small steps one at a time is a key to successfully merge your patches. I'm not saying that merging your patches to final goal is a good one. But if you want to contribute effectively, you have to let your ideas through to the maintainer or the OTP team or whatever who controls the code. So, and here comes the last tweet. I'm going to read it aloud again. The key is a constant discussion around the changes. So it's all about communication. And if you're not interested in the other part of this presentation, please remember that the core of this presentation is that the constant discussion around the changes is the most important part to make a better software or a better contribution and effective contribution. So, okay, let me go to a little bit details about what to do to include your stuff to the OTP. When you're going to issue a pull request or PR on the GitHub, OTP is entirely maintained in the GitHub. You need to tell what you're going to do with it and how it changes and affects or does not affect other modules. What and how is easy to describe. At least in pull request issues, you just document them. But the harder part is that what it will affect, what it will not affect, determine the range of what will be affected. That is a hard part. And for example, in the random module, almost everyone using the random module will be affected. And the range was huge. And it affected RabbitMQ. RabbitMQ actually wrote their own wrapper code to switch between random and random module. I personally didn't think that kind of code is needed, but that's their choice. And some people simply switched the module header of random into rand. In many cases, it will work. But the bottom line is that that it affects lots of people. So it takes almost 2 years to migrate. So of course, I know that, and with the OTP team, we discussed a lot about how to migrate or how to make those programmers easier to migrate. But after all, somebody has to suffer from the changes. So at least you have to document that before sending your pull request. And you will also have to include test cases. Test cases is a must. I have to confess, some of my code doesn't include test cases. I'm bad. I'm sorry. I'll be punished about that. But the reality is that without test cases, OTP will never ever accept your code. And there's other important thing, type specs. Type specification for all global means that which is visible from the external modules or applications. These are required. And I also have to confess my sin that I forgot to write some of the important type specs in the jump function. Recent commit to the OTP. And Dan Goodmanson, my partner, accidentally put into the production code. And the author of Dialyzer, Professor Kostis Sagonas, he's a very great and emotional person, immediately responded that you were doing the wrong thing. And he literally scolded Dan that why didn't you check that? But the story didn't end in this way. Professor Sagonis immediately wrote a patch for the building system of the OTP, which uses the Travis CI, so that every part of the code will be tested under the Dialyzer. So he's not just an emotional person. He's a very practical person. I admire him a lot. So this kind of attitude is required when you really want to commit to the OTP. You have to be proactive. Okay, so let's get back to the last one, documentation. You have to describe what you do in the Erlang manner, Erlang manuals manner. I don't know whether Erlang manual is really readable or friendly for the newcomers, but those are well described. And one good thing for a non-native English speaker like me is that it's not full of American slangs or British slangs or whatever. It's written by Swedish people, so they're using the common expression, which is much understandable for me like Japanese. So, okay. Anyway, write a good documentation, good test cases, and of course sufficient type specs. Okay, and how to issue a pull request. When you try to issue a pull request to fix a bug, report bugs before the pull request. Report it. I repeat it 3 times because so many people are complaining that bugs on Twitter or everywhere, maybe on a Stack Overflow or everywhere. That is okay, but without reporting it to the OTP team doesn't really know anything about it. So report bugs before sending a pull request. Of course, you can do it all together. And choose the right branch. Right branch means there are many branches in OTP source code tree. For example, when you put the new feature, it has to be on the master branch. Master means that it's on the development. It's not on the release. For example, for the time being, as of now, the going to be OTP 20 is on master branch. On the other hand, there are main branch. There's main 19 and main 18. Main 19 is for version 19, and main 18 is for version 18. And bug fixes for specific releases should be sent into those branches too. So you got to choose the right branch. So, the next topic, it's about separate commits for separate changes. Please modularize your code, modularize your commit so that the OTP people can understand what you're going to do with each part of the commit. And this is a requirement so that OTP team can use the command called git bisect. So that each of the commit in the git log can be examined independently. And so make sure each commit works. And OTP team may request you to squash multiple commits. For example, if you commit one line for each commit and you throw them 100 commit in the same pull request, they will understand, but they will almost always request you to squash 100 commit into one. So get accustomed to use the command called git rebase. And it will benefit you to streamline what you really do in the OTP, GitHub. Okay, next, talk about the communication with OTP team. Maintaining steady communication is important, as I told you in the previous log tweet. And OTP team may send you some private email for the contents which is not appropriate to be put on the GitHub issues. So use them, respond them wisely. Maybe they want to ask you for something before make it publicize something. So the bottom line is keep closer communication. And the other trivial, I'm going to tell you a trivial thing, that OTP team work in Sweden time. Sweden time, 8 hours ahead of now and from the California time. And it will soon be 9 hours ahead because the next week, because Europe and US, Canada, daylight saving time schedule are different. Remember, they are different. So your summer time is not theirs. So time zone difference should be respected. And you should also respect their weekends, their vacations, or their holidays, because for OTP team, dealing with OTP is their work, the job, their duty, and their business. Not for a volunteer like me, it's not necessary in that work manner. Maybe I can do it for fun, but for OTP, it's not for fun. It's therefore business. So respect their weekends. Don't expect the immediate reply for what you throw to the OTP people. And the one last thing I have to mention is that OTP team members have to deal with many, many modules and many, many different parts of the Erlang itself. Some of them are dealing Erlang VM together, or Erlang SMP scheduler, or Erlang memory allocator, or garbage collector, or some very difficult part of Erlang, as well as dealing with other modules. So I got to tell you that time for you, if you want to commit the code, time for you is usually very limited. I have 5 minutes. 5 minutes, okay. Okay, I'm going to speed up. Let me move on to how to gain community support for your code. The first thing you got to do is to promote your code. Publish on GitHub and elsewhere. Give talks and conferences like I do now. And write proof of concept and show the problems if it's about bugs. I wrote a C code to exploit the random module in less than 10 hours. And the proof of concept, that proof of concept code finally moved the OTP team to make an alternative, namely run module. Okay. And about code maintenance and support, this is a rather ethics issue, but once you commit the code to OTP, you are responsible for your code. And you are also being asked for bug fix or enhancement. So you got to be ready once you commit your code. And if you just leave it without untouched, old code may be removed by the OTP team's discretion. So if you want your code to be in OTP, you have to maintain the contact frequently. And last but not least, be careful on adding features. OTP people or Erlang people, or maybe Elixir people, they are very conservative on adding features. Okay, on the last topic, Erlang OTP has an Apache 2 license. And license is a very hard part. I think it's a field of lawyers, not for programmers. So I'm not going into the details of legal details. But one thing for sure is that, unfortunately, Apache 2 is incompatible with GPL v2 and v3. So if the code is declared GPL, you cannot bring it directly to Apache, Apache 2 code, including Erlang OTP, unless it is explicitly relicensed. On the other hand, MIT and BSc license code, they are okay to merge. But in general, relicensing is almost always needed. OTP team will ask you once they decide your code will be a part of OTP. So, to conclude this presentation, there are lots of things to deal with OTP team, and this is kind of hard things to do. But I want to emphasize that Erlang community and OTP team always need your help. because they are severely understaffed, and the volunteers for Erlang performance increase is severely understaffed, and they need to get more talents and people to improve the software. I'd be glad if this presentation helps you to understand the situation of OTP team and how it's maintained. Now let me show you the reference. The time is limited, so I put the document on web specific for this topic. And if you get the slide, you will be linked to the document online. And before finishing the presentation, I'd like to thank GMO Pepabo for supporting this presentation as a research activity of Pepabo R&D Institute, where I'm working as a guest researcher. And acknowledgement for Dan Gudmundsson. He's a superb person to make the whole optimization of RAND module. And Sebastian Vigna, who is the inventor of the new algorithm of ExerShift star and plus. And Dan actually requested Sebastiano for writing an algorithm specific for Erlang, and Sebastiano did it. So Sebastian did a very cool thing through Erlang. And I also thank Erlang Solutions for giving this chance to talk. So thank you. For any questions?
Yeah. Small question about random. Did you consider keeping random and just improving it, like fixing all the deficiencies there, like a lack of getting rid of initialization phase and improving the periods without writing a separate module for that?
Yep. Okay, so can I understand? Can I rephrase to you that do I think random module is going to be still be improved in new or should be?
Instead of writing a new module, just improve the old one.
Okay, instead, his question is about any possibility of improving the old module instead of writing a new one. That is impossible. Because AS183's base algorithm of random is designed in 1980s for 16-bit computers. And although at that time it's new and it was innovative, but I no longer recommend it for any use, any production use or any testing use. So if you want to switch to, if you have a lot of random number routines, switch it to RAND immediately, right now, please. I'm sorry, this would be your inconvenience, but please, okay?